In our last number 43, so 43.2, we're looking at a law of conservation of momentum here. Initially, you have your rod and you have your disc circling around down below. This has an angular momentum already, and we can find that angular momentum by taking the I1 and doing it times omega initial, our equation for angular momentum. Now, when that second object drops down, it has a second moment of inertia, I2. So when it drops down, our angular momentum is going to be conserved, but our moment of inertia is going to change, and thus then our angular velocity has to change. So I can say that L naught has to equal L. So initial angular momentum is equal to final angular momentum. Our initial angular momentum is just I1 times omega initial. Our second angular momentum is going to have to be the combination of the two, because now when they slide down together, that second object is going to sit on top, making our total moment of inertia equal to I1 plus I2. And that's going to be our final omega. And so I can solve this for my final velocity to be I1 over I1 plus I2, this whole thing times omega initial. And so that's going to be our final angular velocity. Now the second part is they want us to look at the kinetic energy and find out how much that kinetic energy decreases and what the ratio is going to be. Well, remember, in order to find a rotational kinetic energy, that's going to equal 1/2 I omega. So that's our basic one. So if we want to find our initial kinetic energy, so K naught, that's just going to equal 1/2 of I1 times omega I squared. Our final kinetic energy is going to equal 1/2. Now it has the summation of the moment's inertia, so I1 plus I2, and now we're going to multiply that out by omega final. Now omega final is up here, so I'm going to quick just square this. So omega final squared, so it's going to be I1 squared over I1 plus I2 squared times omega initial squared. And so if I pop that down here, this will equal I1 squared all over I1 plus I2 squared times omega initial squared. So what I can do is now this one, I1 plus I2, is going to cancel out with one of these. So rewrite, so K is equal to 1/2 of I1 squared over I1 plus I2 times omega initial squared. So that's going to be our final kinetic energy. Now we can find the ratio by setting one over the other. And so I'm going to take and put K over K naught. And so K initially, remember, is equal to 1/2 I1 times omega 1 squared, sorry, omega initial squared. And then we divide that by 1/2 of I1 squared all over I1 plus I2 times omega initial squared. So what ends up happening, and I've got to find my other pen here, what ends up happening is the 1/2s will cancel out. The omega initial squares will cancel out. And then I'm also going to cancel out one of these I1s. There. Now, you know what? I flip-flopped that. My fault. So I flipped up this. This is K over K naught. It should have been K naught over K. That's what I initially did. I apologize for that. So now, basically, since I've got, if I do K naught over K, that became I1 plus I2 over I1, flipped. So I have to find the final answer, the one they asked before, which was K over K naught. That's going to be I1 over I1 plus I2. So that's the ratio between K and K naught. Yeah. Alright, so hopefully everybody can see that. Alright, I think I did that right. Yeah, so it's going to be, yeah, K over K naught. So you can tell that it's going to decrease down, the ratio is going to decrease, the kinetic energy is going to decrease. Okay, hope that helps.